Hi everyone, happy to have you here today. Today we will talk about Timelocks. It's a feature that has been enabled in the last release of Tezos Oxford 2. I will discuss about what it does and how to use it in the Ligo language. So what is a time lock? So time lock allows to temporarily hide the payload of a smart contract for the time necessary to have it included in a block. The payload is then decrypted in the smart contract and can operate as before. We will talk later about a chest. So a chest lock with a key. So you put a secret inside the chest and only the creator can unlock it quickly. If you don't have the key, you have to search for the key, but it takes some time. And as the creator of the smart contract, you will set the difficulty for that. It's a replacement in a kind of replacement part, what we call the pattern commit and reveal. In commit and reveal, we did an encryption about a secret, and then we reveal the secret, and we give also the tools we have used or the secret we have used to encrypt this secret. The Timelock implementation is also interactive, but is more convenient than the commit and reveal. In the commit and reveal, you need participation of everyone, and if someone wants to lock the sequence of the flow, he can omit to reveal the secret, so you need to play with timeouts. On the time lock, it's a question of time, so it's an estimation about the time that someone finds the key. And after a certain time, we consider that someone could have found the key and so could have revealed the secret, so it could be anyone. A use case that you may know, maybe this application. So it's a mobile game that I deployed some years ago about the Shifumi game. So it's scissors, stone, paper game. So when you have two players and they need to put the choice, their move, what they want to choose, is information that can be on chain. So you understand that you have to encrypt this data. So in this version of the game, you have the commit and reveal pattern, but it applies also if you want to have an implementation with Timelocks. About Ligo, so we have re-implemented in Ligo the functions, the instruction from Michelson. So you have these new types available, chest, that is the Timelocks chest, so where you put the secret on it. The chest key that it used to open the chest and to find what is inside the payload. And you have the function open chest. So you give a key, a chest, and a time that is a difficulty. And it returns you either bytes or not, depending if you success to open the chest or not. We can put only bytes because it's generic types inside of a chest. So these are on-chain operations that you can use on your smart contract. On the Ligo test framework, you have access to two other functions. So using test, you can create a chest. So you put a payload inside that doesn't have to be encrypted because the chest will be encrypted. Also, you put an argument that is a time difficulty, and it returns you the chest and the chest key as you are the administrator. There is another function is to search for a key. So if you are not the creator of the chest, you don't have the key, so you can search for the key of the chest. So you give a chest as parameter and the time difficulty, and it returns you after a certain time. That's the goal, that to waste time to search for the key. A chest key that you will use after to open, for example, the chest or prove that you can open the chest. Well, I'm not going to explain you how the Shifumi game works because it's a more complex game. Instead, I will demonstrate how to play with a coin flip game. So a coin flip game is quite easy to understand. You have a coin. The administrator initializes the chest and decide to put a head or a tail inside. Then a player comes. He has to play a guest and submit a guest on the smart contract before anyone is able with the time to try to open the chest. there are two choices for finishing the game, or the administrator send the key after a player to guest and open the chest to resolve automatically the game, or either someone don't have to wait for the creator to do an action and try to get the key and reveal at the same time the result of the game. Okay, I will give you a short demo in Ligo, and I will show you the code that implements this game. So here we have a Takeria project where we have some Ligo files. We have the smart contract that is here, and here we have the test file. So I will start with the test file first to explain the scenario and run the test, because it takes some time to create the chest and also sometimes to find the key. So let's first have a look on the test, and then I will explain the smart contract. So first of all, talk about time difficulty. Here, what means the time as a natural that you see on the parameter is the number of iteration of a square. So this is the way behind the hood that the difficulty is made. It's a kind of a sequence of calculation that takes time and cannot be parallelized. So to find what is the worst case scenario, so if you have a very powerful machine, even if it's not doing parallelization, you have to see in which time a block, during a block time, for example, a key can be guessed. So what I do here, I did some tests on my laptop, and I found this number for a block. So for a block time of 15 seconds, I need to have a difficulty of 3 millions. Okay, so in my case, I set this parameter here, but it's not the worst case scenario. Okay, the worst case scenario here is if you use FPGA on Amazon, that's the faster that can exist is 600 millions. So you see that the difficulty has to be higher for a machine that, a hardware machine that has been designed especially to break the key. I would take an average, and I consider that someone want to try with his laptop. Okay, so I set the difficulty as an average, not at worst case scenario, and I will multiply by a number of block difficulty. Means here I say that I want to protect my chest and access to the guest to the chest key for 5 blocks. So I multiply the difficulty by 5, and I have my difficulty level. Okay, so that's how I initialize the difficulty. I create the chest like you saw before. I put a secret on it, so no one has to know. This is done off-chain. What I put inside of the chest. So we put a head, and with this difficulty, return me the chest and the key for the chest. And then I deploy my smart contract that we will see just after. With this storage. So I initialize with a chest. No one has gets what is inside. I put the parameter I use for doing, calculating the difficulty. This will be the result of the game, and I need to know at which block started my game. That for calculation you will see later. I have 2 functions. Once I have deployed the smart contract, I will simulate someone will try to guess something. So here he guesses ahead, so we will win, I know. But I can do another test to see that it will fail. And I can finish a game. And when I will finish a game, I will simulate that someone try here to find what is the key of the chest. That's why it will take some time. It will take some time first to create the chest here, and it will take the same time to find the key as creating the chest. It's important to know. So I will run this test. Like this. It will take about 5 blocks, like I said, to create the chest and to guess what is the actual output. It should be fine. Let's have a look now on the smart contract itself. So I have a type, variant type, head or tail. There are my two values that are possible. My storage, I store number of block of difficulty, what is the difficulty that I want to set, or that's in my laptop difficulty here. The chest that is stored inside at origination. The guests are in bytes. So here we have the coin inside. They are not bytes, but I will pack to have bytes. The result will be a boolean if the guest is right or wrong, and when I will start. So it will be the level when I will deploy my contract here, the start block. So it's important for the next step. So I have my two function guess. Guess will only register a guess from a participant only if. So I look on the level of the chain to see what is the head number. So here I get the level, and I look that is less than when I deploy the chest. So that's why I need to mark when I deploy the chest. This is the start block when I deploy the smart contract and I deploy the chest, plus the difficulty I want to have here. If you submit later, I cannot guarantee that someone opened the chest and cheat, so I will just fail. So you have to be fast and answer before 5 blocks, what it means here. To finish the game, someone needs to provide the key for the chest. So it can be, like I said, the administrator, or in my case, someone will try to find the key. And I will try to open the chest with this key. I give the chest, and I need to put here, I need to know what is the difficulty to match. So I report the difficulty here. I look inside because it's an optional, the secret optional. If there is nothing inside the chest, it means that the key is wrong, or the chest provided is not the right one, or so here it's impossible because it's on my storage, and here the difficulty is not the right one, so here also it's not possible because it's stored in my storage. So only if the key is wrong is a possibility. The second case is the chest is open. In this case, I take the secret that is inside, so it's in bytes, and I compare this secret with a guess of the player. If it is the same, so the result will be true, and I can read this information on chain to see if the player is right or is wrong. Okay, so you see that the code is pretty small. What really takes time is here the calculation of key for the chest. So I put a protection 5 blocks, but it will take 5 blocks to create the chest, and it will also take 5 blocks to find for the key. Okay, because the time for creating the chest is the same time of creating the key of the chest. That's why it takes a bit of time. So in few seconds, normally you will see the result of the test that will appear here. Okay, and as you see now that everything is fine. So I have the result here that is true. I have no errors, so everything has finished well. So I have the difficulty, the number of blocks, the final difficulty here. The chest is encrypted, so you don't see what is inside of it. And you see that someone here put a guess, so the guess is registered before the 5 blocks come. And then the resolution here is correct. Okay, I hope you enjoyed this video. You understood more how to use the Timelocks and for what you should use this Timelocks. So for gaming and the money game, but you can use other application when you need to store a secret for a certain period of time and reveal it later. Have a good day and see you next time for the next video.